Hello everyone, how's it going? Vasco here from the Angular University. Welcome to the conclusions lesson of this course. So this is not the last lesson of the course. After this, there is still one last section where we will show how to build a server like the one that we have been using so far. Right now, let's do the conclusions of what we have learned by building this chat application. So as we have seen, the use of a store architecture is really all about moving the mapping between the model and the view model from the server to the client. This solves a whole set of problems that we face when building more advanced and complex user interfaces. For example, problems that were otherwise hard to solve, such as the Facebook counter problem, are solved in a very simple and standardized way using a store architecture. The way that this works is we bring a slice of the domain model from the database across the wire. So the result of our server calls are domain models and not view-specific models. We take that small slice of the database and we put it in a client-side in-memory store. Once the data is there, we are going to derive view models from it, but we are going to do it on the client side last second before injecting the view model into the view. This approach makes it very simple and very maintainable to have multiple views of the same model on the same screen. Also, we have learned a way of structuring the different components of our application. We have learned that there are different types of components. For example, we have learned about smart components that are components that are aware of the store, so they don't need to be container components. But in the case of our application, the two smart components that we had were top-level components. So this type of components get the store injected in the constructor, so they are aware of how to retrieve the data of the application and they are aware how to map it into the local view. What they are not aware of is how does the data get there? Is it via a WebSocket, an HTTP service, a cross-origin request? That is transparent. The smart components simply receive the store and they subscribe to it because the store is an observable of application state. It's the smart component that plugs in the selector functions that do the mapping between the in-memory application state and the view-specific model. Now, the smart component also triggers actions, for example, server requests, but it does not do so directly by calling backend services. Instead, the smart component will use the store as sort of a facade service to interact with the service layer, and it will dispatch into the store actions, which are essentially commands. So each smart component is aware of the store, but the multiple smart components of our application are not aware of each other. With this architecture, we cannot introduce tight couplings between multiple views of our application. We have also talked about presentational components, which are responsible for taking data as input and rendering it out in HTML to the screen. Typically, one top-level container component, which is usually a smart component, will have a local tree of presentational components, such as the thread list or the message list components that we have implemented in this chat application. We have also talked about immutability and how it relates to presentational components and the store architecture in general. So we have learned that we should use NGRX store freeze to ensure that we are not doing mutation operations in our reducer functions, because that would break essentially the store architecture. Another thing that we have learned is that if our application is having front-end performance issues, and this should be confirmed by doing some sort of profiling, if we run into that situation, we can fix it by leveraging the on-push change detection mechanism of Angular, which essentially causes the synchronization between the model and the view to be done only if we pass in a new input to the component. So this optimization should really only be applied to components that receive their data as inputs. For smart components, that is not the case. Again, it's important to bear in mind that this is an optimization. We should put it in place if we really need it. And if we put it in place, it's important to make sure that the result of our selector functions, which essentially do the mapping between model and view model, it's important that that output is immutable. Otherwise, we are going to run into change detection bugs if we use onPush with mutable objects. We have also learned about the NGRX effects library, and we have understood why this is really an essential library to use in our application. So with it, we can really structure our application into different services that are not tightly coupled to the store. So with this, we can detect actions that are emitted by the store, and we can produce side effects in response to those actions. An example of a side effect is sending a HTTP post to the server to save some data without receiving any data back to inject back to the store. So we have a clear separation between the view layer of our application that only interacts with the store and the rest of our service layer, which again only interacts with the store via the actions observable. So as a final summary, the NGRX ecosystem gives us a clear way to structure our application. What do we put in our smart components? How do we separate our view from our service layer? How do we structure our service layer? What data do we bring across the wire to the client? How do we build complex user interfaces that have multiple views of the same model on the same screen at the same time, keeping all the view models in sync? How do we do that without introducing tight couplings between the multiple parts of the application or triggering frequent refreshes? How do we build complex user interfaces while keeping a great user experience and our code maintainable? We have answered all these questions in this course, so we now know how to build a full Angular-based application top to bottom using NGRX Store and the NGRX Reactive Extensions ecosystem. I hope that you have enjoyed the course. I hope that you have enjoyed building this small chat application step by step. Please stick around because in the next section we are going to see how can we build the server that we have been using so far. It's coming right up in the next lesson.